All right, good morning. You have an exam on Thursday. We've talked about that in previous classes, but just to reiterate, there's going to be two parts on that. The concept questions, where you're not allowed to use your formula sheet that you're preparing, and then problem-solving questions, where you can use a page of notes that you create. And that page of notes should just be one side of a 8.5 by 11 size paper. Also on Thursday, the homework number 10 is due. And we're going to do another economic service life oriented in-class exercise today. And so that assignment that you have due, replacement and retention, is related to the economic service life that we covered last week. Okay, so any questions on the announcements? Yeah.
When I was checking for to start the homework like Sunday, I noticed that there was like no problem sheet to access. So
You're talking about this homework number 10?
Yeah.
All right, I'll double check. It may not be enabled on MU Online yet.
Well, I checked like Sunday and then yesterday to start work on it early. And there was nothing there.
Okay. Yeah, I'll take a look at it. It may not be enabled yet on MU Online.
Okay.
All right. Yeah, if you face that in the future, just go ahead and send me an email, and that way I can take a look at it sooner. All right, the other long-term announcement is that on Tuesday, November 12th is when your project is due. So I hope that you're making progress on that, and read over the handout that I gave you on the project, and please let me know as questions arise. Thank you. All right. So today we're going to be talking about a specialized application of economic service life analysis, and that is replacement studies. In the picture here, it's showing the control panel at a couple of chemical plants. And it's just an illustration to give you an idea that on the left is some old analog dials that are indicating the pressure and flow rate and what's basically going on with the chemical process at various points in the plant. And on the right is an automated system with lots of flat screens and computers, and actually you can see that there's no people in the photo there, because a lot of the advantage and attraction of automated control systems is that it requires less user input, and more things can be automated and fewer mistakes will be made. But the question is if you already have a functional system and it works, it's not broken yet, and it's not obsolete, how do you know how long to own equipment versus when to replace it? And so that's the crux of a replacement study. And when you're conducting a replacement study, your primary objective is to minimize the cost of alternatives. And what we assume is that when you're doing a replacement study, that both alternatives are able to meet the required objectives. And so that's to say that both, by the way, if you're not watching the lecture, some of the things in here may be important for a little bit later when we're working on the in-class exercise. You assume that both of the items are able to generate the same income. You assume that the difference arises from their cost. And so both of them are meeting the required specifications to produce whatever is being generated, or if it's a cost alternative, like related to city use or nonprofit use, it's not necessarily about generating income, but it's going to meet the needs of the people who are served by it. Sometimes in replacement studies we don't know the time horizon, and you just compare the two alternatives over 1 year, over 2 years, over 3 years, and you just keep going outward until you see the costs starting to rise, for the reasons that we talked about on Thursday, just how the longer you own equipment, the more maintenance and operation costs contribute to the overall weighted cost. So if the study period isn't specified, then you just try and identify the economic service life of both alternatives and then pick whichever is lowest. Economic service life analysis, remember, is that procedure where you're not only looking at the initial purchase price, but you're also accounting for the salvage value of the equipment. And what's it called when we annualize the difference between the initial purchase price and the salvage value? It has a specific name. That's right. Very good. So capital recovery is the annual amount that takes into account the initial purchase price and the salvage value, so that instead of maybe buying a truck at year 0 and selling the truck at year 10 and being on the hook for the entirety of the difference between those two in lump sums, capital recovery asks the question, if you're going to pay an equal amount every year for that equipment, how much would that amount be? So economic service life takes into account the capital recovery, and then it also annualizes the annual operating costs. And remember that annual operating costs over time increase. So if you own something for 1 year, it's probably still in good condition, and so the operating costs are lower than if you own something for 8 years. But the thing is it's a curve that's going up. So to annualize that constantly increasing annual operating costs, you're taking all of the different amounts to the present, and then you're spreading it back over an even annual series. So that's just in a nutshell the economic service life analysis. So for two alternatives, you do economic service life for the Defender, which is the existing equipment that you already own, and then you'd also do it for the Challenger. And you'd pick whichever alternative has the lowest annual worth of costs, and that's how many years you'd also own it. But one important caveat is that this is all projecting into the future. You're assuming that a piece of equipment in a certain number of years will have a given salvage value. And so maybe your estimate today isn't accurate a year from now. You know, for example, if you're doing an economic service life analysis for a certain car, you may assume that the car is going to hold its value really well into the future. But if the car manufacturer comes up with an updated model and suddenly the old model is less valuable because nobody likes the style of it, or maybe the engine is less powerful, so if things change, then your economic service life telling you how long to own the equipment could vary. And so in practice, in real world use, when you're doing an economic service life analysis, you'd revisit the analysis every year to make sure that the assumptions are still valid, and to make adjustments where necessary. Okay, so the first economic service life analysis comparison we're going to do in this replacement study is where there's no study period specified. That is, you just own the equipment for as many number of years as the lowest annual operating cost plus the lowest capital recovery cost. And so this is going to be largely a repeat of what we did in class on Thursday, a good practice to get another economic service life analysis done. The one thing I'll remind you is that when you own existing equipment, you assume that its first cost is the value of the equipment. Remember, when you're comparing alternatives, if you decide to keep what you already own, it's like you're paying what it's currently worth. And so if you decide to keep your Ford instead of buying a Chevy, then that means the first cost is whatever the market value of the Ford currently is. And so I've given you kind of the same clues on how to calculate each of these columns like we did last time on Thursday. So the formulas for column D, E, F, and G are provided. But then there's some other blanks here that you're going to have to interpret from the problem statement. Let me refresh your memory on a couple of things that we do in an economic service life analysis. Okay, the first thing is that the first cost is negative for the Defender. So if its current market value is $15,000, then keeping it is the same as not getting that $15,000. So be sure that you put a negative value for the first cost. The other thing I'll point out is that the market value, though, will be positive. And so the market value amount, when you do own it for 1 year and then at the end of that year you sell it, the $12,000 would be a revenue. And then finally, you can see the operating costs for a given year have been put into the spreadsheet. And so then in column D, what we do for the NPV function is we do the NPV of just how many years of the accumulating operating costs have occurred so far. So it would be the NPV of just this for year 1. In year 2, it would be the NPV of 2 years cumulatively. In the 3rd year, it would be the NPV of 3 years cumulatively. So that's what it means here where it says NPV of range so far. It means how many years have you had so far, and then you do the NPV of the range of those operating costs. The formula here where it says E plus I, that's supposed to be E plus F. So that's total is the sum of the operating and the capital recovery. So the two components go together for the total cost. There will definitely be one of these on the exam. Wait, did I just say that or think it?
I didn't hear anything.
What we should find is that the best alternative is the defender and owning it for 3 years. That's the alternative and the ownership period that gives us the lowest total cost. Let me zoom in on the calculations for the Challenger so that you can see those a little bit better. Now, comparing the Defender to the Challenger, I want to point out something. I got a good question just now. Somebody asked, can you only compare like year 1 versus year 1, year 2 versus year 2, and so on? And the answer is no. You actually find whatever is the lowest on either of the options for however many years. And so you don't have to compare year 3 of the Challenger to year 3 of the Defender. It's just you compare any of the Defender ownership durations to any of the Challenger ownership durations, because what each row indicates is how long you're owning the item. And so, for instance, row 5 for the Challenger, what that means is that if you buy the Challenger and you own it for 5 years, then your overall cost of ownership during each of those 5 years is $19,126. And what we can see is that actually the Defender is quite a bit more competitive beyond the 1-year ownership. So if you own the Defender for 3 years, that's going to have the lowest cost of operation. And so what you would do is you'd say, all right, we're planning on owning the Defender for 3 years. Next year we're going to double check and make sure that maybe the data hasn't changed. But as long as you revisit that analysis each year, then as things stand right now, it looks like owning the Defender for 3 years is going to minimize our costs. And then at the end of that period, then you'd consider what are the best two alternatives. And so it wouldn't be with existing equipment perhaps. You'd still consider the Defender, but at that point it looks like the operating costs are going up, and so maybe a Challenger would finally be more attractive after the 3 years. All right, I'll give you another minute or so to finish this one. At the very least, save the file if you need to work on it a little bit later, because I want to tell you about a different type of replacement study. You know, this one was where we don't have a study period specified at the beginning of the analysis. We just go with however many years gives the lowest cost. The next kind is where you do have a study period specified. Okay, if you haven't quite figured out the spreadsheet so far, just keep in mind that the solution is in the recording, and I went through all of the calculations, and so if you want to rewatch the video, you can see which cells were included in the formula and where was there a minus sign and all that sort of thing. We need to move on and talk about the next situation where a study period is specified. When the study period is specified, usually that's a case where you know you're going to need a certain piece of equipment for a certain number of years. For example, if you're beginning a new construction project that has a known lifespan and you want the equipment to last for that duration, and you're comparing alternatives specifically for that duration. And so the approach in a situation like that is to prepare a cash flow diagram for both alternatives. And one common thing is that you have existing equipment and new equipment, and the existing equipment is going to last for a short number of years and the new equipment would last for longer. And so sometimes the study period is the life of the new equipment that you're considering. And so, you know, if you had a steamroller that you think will last for 10 years, but your existing steamroller only lasts for 3, then the question is, I want a 10-year comparison window, but you're going to have to do something during the 7 years following the existing equipment. And so you have to have some sort of a method to account for the different useful lives. And remember that we've done contract services before, where if you have 2 different lifespans, one of the ideas is just to rent equipment over the remaining years for the shorter lifespan. The other alternative is to buy the Challenger after the Defender is retired. So that means you'd buy the new equipment after you use up the remaining life of the existing equipment. Okay, so in the example we're looking at today, here's a cash flow diagram that illustrates the 2 alternatives. Our Defender is only going to last for 3 years. And so its current market value of $70,000 means that if we keep the Defender, it's as though we're incurring an expense of $70,000, because if we keep it, that means we can't sell it. So that's why in the cash flow diagram, the current market value is shown as an outflow. You can see the annual operating costs each year is $30,000 for the Defender. The operating costs are even higher for the Challenger, but the good news about the Challenger is it lasts for 10 years instead of lasting for just 3. So what we're going to do if we choose the Defender alternative is we have to do something to make up the remaining years. And so what it says in the problem statement is to purchase a replacement. Rather than using contract services, our plan is to buy the Challenger, and we're going to have the capital recovery during these years of operation of $146,475. That happens to be the capital recovery of the Challenger over a 10-year horizon. And so we have both the capital recovery costs and the annual operating costs. And then these dashed arrows here are just showing you that the item is transferred outside the project, and so even though the equipment lasts for 10 years, we don't have to consider the full value of all of those 10 years. All right, so what we want to do is we want to find out what is the annual worth of the Challenger and the annual worth of the Defender. And you may need a separate piece of paper for this one, because my suggestion is that use the 10% table that's at the bottom there. And so take everything to an annual worth basis. So in the case of the capital recovery, this $146,000, for example, it may be most convenient to combine that with the annual operating costs and take it all to year 10, and then from year 10, which is a single future amount, then find A, the annual amount. You'd have to also annualize the $70,000 that's at the present and take this annual amount to the present and then annualize it over 10. We want to find out for the 10-year the 10-year timeline, what's the annual equivalent of each option, and we would want to select the cheapest of those two annual equivalents. So this is factor table practice, just kind of refreshing your memory on how to use the factor table. Remember, a pretty good habit when you're doing problems like this is to write an outline of what your solution strategy is. Before just starting right into the calculator, kind of do a basic outline on your page where you're saying, maybe like label certain series. You'd label this annual series, and you'd say take it to 0, and then you'd label different components of the defender and just kind of provide a pseudocode of what the steps are going to be that you calculate later on. So when you have a complicated cash flow diagram like this defender, I think it's a good habit to try and identify the different pieces. You can see that I've broken it up into a single present value amount, this small annual series of 3 years, another annual series of years 4 through 10, but it's shifted, so we're not going to be able to spread it out over A in a single move. Both 3 and 4 can be combined together, but they're going to either have to be taken to the future and then spread out over the annual series amount, or taken to year 3, then from 3 to 0, and then from 0 spread out over 10. So there's a couple of different possibilities there, but I just think it's really important if you clearly demark what are the different components in a complex cash flow diagram. So the Challenger is relatively easy to find the annual worth of a Challenger. It's just the operating costs and then annualizing the first cost, combining it together. The Defender, though, is more complicated, and so the 4 steps that I identified was the present cost, which I leave at the present. My take was I'll move everything to year 0 and then spread it from year 0 out over the annual series. And so 1 is already at year 0. 2 I have to take to year 0, and I can do that in a single step. And then 3 and 4 I'll take to year 0 first by taking it to year 3 with P/A, then from 3 to 0 with P/F, then from 0 spread out over the annual series with A/P. Okay, so then that's the steps that are summarized here. If I zoom out too far, then you really won't be able to see. Let's do this. I'll put this solution back up on the screen in just a second. I know some of you have finished it already, and I don't want to keep you any longer. I just wanted to let you know that if that homework 10 isn't already on MU Online, I'm going to double check on that immediately after class. Just be aware, it's only going to be a single problem. So this homework assignment is one problem. So I think you're going to be able to solve that relatively quickly in preparation for the exam that you have on Thursday. I didn't want to overload you too much with a huge homework assignment. So this homework number 10 is just a single replacement retention type problem. So you'll need to submit that prior to the exam. Make up your page of notes to bring with you for the test on Thursday. So if you have any questions as you're preparing, as you're studying, anything you want to go over, feel free to stop by during my office. I'd be glad to help you out with that. So I'll see you for the test on Thursday.